All right, so let me do some quick review of factoring. One of the simplest things we can do is factor out a GCF. But since we've got three terms, notice that they all have a 6 in common as a factor. So we can pull that 6 out, and then notice they also have an x to the third in common. And so what's left over from the first term, taking 6 from it, it would be 6 times 2. We took x to the third away from x to the fifth, leaving behind x squared. From the second term, we took a 6 away, so leaving 6 times 3. We left behind 1x. And then from our last term, again, think what times 6 would make negative 24. That would be negative 4. And then we took away all the x to the thirds. So this here would be how you factor out a GCF from a polynomial. Now, what if we had something like maybe with a negative in front of it? So that's one example. So usually we want to factor, if we are factoring a GCF out, which in this case 4, 8, and 12 all have 4 in common. And in a lot of the problems we do, it will be helpful to factor out the negative. Okay, so leaving behind just the x squared from the first term. Now again, think what times negative 4 would give me a negative 8. That's going to be a positive 2. The x is still there. And then negative 4 times a negative 3 would give you that 12. So this here is just factoring out the GCF. All right, let's try another example of when we need a factor by grouping. Now in this case, I've got my 4 terms, and notice that this middle guy, when we make our groups, has a negative here or a minus sign. So here's how we're going to handle this. Again, still make your first 2 terms to let those be your first group. Now if you make your second group immediately like this, it now looks like we're multiplying these 2 groups, which is not the case. So here's how we're going to handle this. What I would do is take that negative and cheat it really close so that it's in the second group, and go ahead and include a new addition sign. Again, that's still, these 2 guys still are just a negative. Okay. Now when you make your second group, now we see that we're still adding and subtracting 4 terms, and that negative sign definitely belongs in the second group. So make that little adjustment there, and now we're going to factor the GCF, just like we did in the last example. They both have a y in our first group, leaving behind an x minus 4. Again, we're hoping that this will match the second binomial we're about to create. When the second group has a negative here, you do want to factor that negative out with the GCF. So we're going to factor out a negative. They have a 2 in common, and in both of these second terms also have an x in common. So what's left behind in the first term? Just x. Okay, what times negative 2 will give us positive 8? That's going to be a minus 4. And again, we took the x out, so that's no longer there. And you can see now that these 2 binomials match each other. If they don't, something's not going right. So we can factor, again, imagine if all we had was just ya minus 2xa. That a is something in common that could get factored up to the front, leaving behind the y minus 2x. That's exactly what we're doing here, except that we don't have just a, right? We don't have just a that we're factoring out. We've got this binomial x minus 4. But because x minus 4 is something that each term has in common, we can factor that up to the front, leaving behind what's left over. Y got left over minus the 2x. And then that would be the end for factoring this. This is a trinomial. We're going to factor a trinomial. It's 3 terms, so it's a trinomial. And also notice that the leading term has a coefficient. The leading coefficient is a 1. right there. Anytime that it's a 1, these are usually a little easier to factor than if it had something like a 5. We'll talk about that case in a little bit. But when the coefficient is just a 1, again, you don't have to write the 1, just trying to point out that it is a 1. We want to factor this into two binomials that when multiplied would equal this. What we do is we consider this last guy, who is we'll just call it C, our constant. B is this coefficient in the middle, and then A is that one up in the front. That's A, B, and C. So what we want to do is make a little shopping list. And our shopping list is this. We're interested in finding two integers that when you multiply them will equal C. In this case, a positive 12. We want these two integers that we're looking for to also be able to add together to equal B. In this case, the guy in the middle, negative 8. Now, you may need to think a little bit. I mean, you may be thinking, does it have something to do with 2 times 6? And maybe it does, because we know that 2 and 6 added together might make a negative 8, but what do our signs need to be? Okay, either 2 and 6 need to both be positive, or they both need to be negative. If they're both negative, well, those multiply to make a positive 12. And we also notice that if these guys are both negative, they do add to make a negative 8. Okay, and you might have been trying 3 and 4, but 3 and 4 won't get the job done. 1 times 12 don't get the job done either. So once you found these special guys on your shopping list, that's who you need over here. Okay, it's going to be minus 2 and minus 6. And then, of course, we need the x times the x. Again, this plus 5, this is our trinomial. We want to factor it into two binomials that would multiply to make this trinomial. Well, notice now that our trinomial now has a leading coefficient that's bigger than 1. It's a 10 now. Okay, and so when this is the case, again, think of this first coefficient as A, 27 is going to be our B, and this plus 5 is going to be our C guy. When the coefficient is bigger than 1, you usually want to use the AC method. Okay, we're going to use the AC method to factor this. So we're going to take A times C, which is 10 times 5, and that's 50. Now we're going to do our shopping list again. This time our shopping list, we're looking for two numbers that are equal to 50, A times C, but once again, they have to, when added, equal the B guy, in this case 27. So what two numbers would do that for us? Again, you might try like 5 and 10, but you notice that that doesn't work down here. So you've got to try something else. Suppose we consider 2 times 25. Well, that should work. And it does. We found the guys that we need from our shopping list. Now, unlike the last example, this does not immediately tell us how these are going to factor using plus 2 and plus 25. That's not what's happening here. The AC method has a little bit more work you've got to do. So what is the purpose of this 2 and 25? What it does is it tells us how to split the middle term. We'll have 10y squared, but that 27y is going to split into 2y plus 25y. It just split into two smaller pieces. And the reason for this is now we have 4 terms and we can factor by grouping. Factor by grouping, recall, is make your two groups. So that's all that AC method is. That's the only way that it's different. It has a little bit of a different start, but it moves you into being able to use factor by grouping. And then from there, you know how to factor by grouping. Factor out the GCF from the first guy, which is going to be a 2y, leaving behind 5y plus a 1, because 2y times 1 would give us the 2y. Factor out the GCF from the second group, it's just going to be a 5, leaving behind 5y plus 1. And again, these binomials here must match so that we can factor it out to the front as 5y plus 1 with everything that's left over. 2y got left over, and the 5 got left over. Now, the last thing I want to mention for factoring is just difference of squares. Difference of squares and how to factor these. Now, in general, when you have a binomial that looks something like this, where the first term is some square, and again, you have to be doing difference. It doesn't work for sum of squares. It's got to be difference. And the second term is also some square. The way that it factors is into the two binomials where it's the a times the a. Then it's also for the second part, it'll be b times b. But you need a plus and a minus. Okay, because when you multiply those, you get a squared minus ab plus a times b minus b squared. These middle terms will cancel each other, leaving you just the a squared minus the b squared. Okay, so that's in general. So let's do it with an actual example. Let's say we had p squared minus, again, that's a square, minus 100. And 100 is also a square. Okay, this would factor, just using sort of that outline above, we have p times p. That's how we get the p squared. And then what times what gets 100? That's 10 times 10. And then again, in order to get the middle two terms to cancel, we need a plus and a minus. And it doesn't matter if you do the minus or the plus, whichever one can be first, doesn't matter. So that's how you would factor this example. Let's say we had something like 16 is another example. 16 y to the 4 minus 81. Okay, notice that this whole chunk here, 16 is a square, and y to the 4 is also a square, because you could do y squared times y squared. Also notice that we do have a difference, and then also notice that 81 is a square. So it meets the conditions for being a difference of square. So who times who makes 16? Well, that's going to be 4 times 4. And what times what makes y to the 4? Well, I said that already. It's going to be y squared. And then we need a plus and we need a minus. And what times what makes 81? That's going to be the 9.